Alright guys, so this is 8.6 and it's on finding zeros of polynomial functions of higher degree. So this higher degree would mean like higher than what we've done before. So we've gone up to second degree for quadratics. So now we're talking about third, fourth, fifth, whatever degree. And we can find them all in the same method that we've talked about before. We just have to think a little deeper on it. So how can you find zeros when given the graph of a polynomial function? So we're going to find the x-intercepts. Remember, that's all a zero is an x-intercept. We call them x-intercepts, roots, zeros. All of those mean the same thing. So how can you find zeros when given the equation of a polynomial function in factored form? Remember, this is where we used the zero product property. We're about to talk about what it is, so don't freak out. So the zero product property, and we're going to set each factor equal to 0 and solve. So we're going to factor it, set each factor equal to 0, and solve it. So how do you determine if x is a solution or 0 for f of x? So if x is a solution, then f of x will equal 0. So if x is a solution, then f of x will be equal to 0. So consider the following graph of f of x. So if I'm looking at this graph, it says, what are the zeros? So if you're looking at a graph, it's pretty easy to find the zeros because you're just looking for those x-intercepts. This one has 3 x-intercepts. So the zeros of f of x are those 3 points. So that's x equals -2, which is right here. X equals -1. And x equals 1. So x equals -2, x equals -1, and x equals 1. You also might see them listed as -2, -1, and 1, like this, with the little brackets. So either one of those are correct, either way to write it. Okay? So consider the following fourth degree polynomial. So we just did, this is actually a cubic graph, the way it's shaped. Okay? We also could do a fourth degree polynomial. So if we were to look at this one, it says find the range of g of x for the given domain. So if we're given a domain, a list domain, then we find the output for each of these inputs. So I'm going to find g of -2, which is -2 to the fourth minus 4 times -2 to the second. So -2 to the fourth is 16 minus 4, -2 to the second was 4. So I have 16 minus 4 times 4. So 4 times 4 is also 16. 16 minus 16 is 0. So we'll list all these out in a second, but this is the first part of my range. Then I have g of -1, which is -1 to the fourth minus 4 times -1 to the second. -1 to the fourth. Remember, if I'm multiplying a negative times a negative, I get a positive. So -1 to the fourth is a negative times a negative, which is a positive, times a negative, which is a negative, times a negative, which is a positive. So to the fourth power would be +1. -1 times -1 is also +1. So that's 4 times 1. So 1 minus 4, which equals -3. Then I have g of 0, which is 0 to the fourth minus 4 times 0 to the second. So that's 0 minus 0, which is 0. Okay. Then g of 1, which is 1 to the 4th minus 4 times 1 to the 2nd. So again, that's 1 minus 4, which is negative 3. And then g of 2, last but not least, is 2 to the 4th minus 4 times 2 to the 2nd. Okay, so again, 2 to the 4th was 16 minus 4 times 4, which is also 16. So that equals 0. So really, my range, let's find a spot to put that. I'm going to put it over here. My range ended up being just two numbers. What are those two numbers? Right, 0 and negative 3. I'm going to actually list them as negative 3 and then 0 so that it's least to greatest, since that's how we normally write our range. So does the above domain contain zeros of g of x? Yes. So remember that zeros are when g of x equals 0. So yes. Negative 2, okay, this is one of them. 0 and 2, all three of these gave me 0 as an answer. So that's here, here, and here. I got 0 as an answer. So yes, negative 2, 0, and 2 are all zeros because for those values, g of x is equal to 0. So for all three of those values, when we sub them in, we got that g of x equaled 0. There, there, and there. Okay? So let's look at a third degree polynomial function. This is called a cubic. So this cubic function says find the zeros of the function h of x. So if I'm going to do this one, this is where I'm going to use that zero product property. I have to factor this function first. So remember, when we're factoring, let's throw back to quadratics for a second. When we're factoring, when we factored a quadratic, the first thing we looked for was always a GCF. So there is a GCF here, okay, and that GCF is going to be negative x squared, okay? So negative x to the second. When we factor that out, I have x plus 5. Now remember, the whole point in factoring is that we can use the zero product property. So I have to set this equal to 0 because I'm trying to find when h of x equals 0. Okay? So I have negative x squared equals 0 and x plus 5 equals 0. So negative x squared equals 0, well, that would just be x equals 0. I can divide by a negative and square root and all that, but it'll still equal 0. And then this is x equals negative 5. So x equals 0 or x equals negative 5. Those are my two zeros for this function. Moving right along, let's look at this graph. So consider the following graph of f of x. What are the zeros of f of x? Now, graphs are pretty easy to find the zeros on because, again, we're just looking for those y-intercepts. So we're going to look at this graph and we're going to pick out the y-intercept. So that would be here, that would be here, and that would be here. Don't get tricked. An x-intercept, sorry, I think I said y-intercept. We're looking for those x-intercepts, okay? So we're looking for the x-intercepts. Don't be fooled. We're not looking for the y-intercepts, even though I messed up and said that. I'm looking for the x-intercepts where it crosses the x-axis. So for this case, that would be x equals negative 2, x equals 1 and x equals 3. So negative 2, 1, and 3. Okay. Then it says, what are the zeros of this one? Okay. This is already factored for us. So all we have to do this time is just set each of these equal to 0. So using this, x times x plus 1 times x minus 2 squared equals 0. I have x equals 0, x plus 1 equals 0, and x minus 2. Now, technically, I could put x minus 2 squared equals 0, but it wouldn't matter because either way, whether it's squared or not, it would still give me 0. So I could just pull out that x minus 2 if I wanted. This x minus 0 is already the 0. I could solve this one to get x equals negative 1. That's my second 0. And then square root this one, which is still x minus 2 equals 0, plus 2, plus 2. So x equals 2 is my third 0. So my list of zeros here are x equals 0, x equals negative 1, and x equals 2. So that's my roots, my solutions, my x-intercepts, my zeros, whatever you want to call them. All of those things are these three numbers. All right, here we go to the try it. So consider the function h of x equals x to the third minus 3x squared plus 2. Find the range of h of x given the domain. So remember, domain is x values or inputs. So if this is my x values or my inputs, then I'm going to put each of those into this function. So h of negative 1 means I have negative 1 to the third minus 3 times negative 1 to the second plus 2. So negative 1 to the third is negative 1. Negative 1 to the second is positive 1, so that's minus 3 plus 2. Negative 1 minus 3 is negative 4 plus 2 is negative 2. Then we have f of 1, or h of 1. So h of 1 is 1 to the third minus 3 times 1 to the second plus 2. So 1 to the third is 1. This is just 1, so 1 minus 3 plus 2. 1 minus 3 is negative 2 plus 2 is 0. So this one I got negative 2, this one I got 0. And then the third one, f of 3, is 3 to the third minus 3 times 3 to the second plus 2. 3 to the third is 27 minus 3 times 9 plus 2. 3 times 9 is 27, so I have 27 minus 27 plus 2, so that equals 2. So my range, to write it out, I'm out of room, so I'm going to write it over here. Is negative 2, 0, 2. Okay, negative 2, 0, 2. Are any zeros of h of x found in the above domain? Now remember that zeros are when h of x equals 0. So if we look at these, yes. The 0 is right here. Okay, so x equals 1 is a 0 because f of 1 equals 0. So we're looking for where the value of that function is 0. So then consider the graph of h of x. What are the other zeros of h of x? So this is the same graph from the beginning. So the same graph as A as part A from where we just solved it. So this is the graph of that function. Let's look and see what the other zeros are. So I already had that 1 was one of my zeros. So that is right here. Okay. My other zeros are right here and right here. So x equals, now to determine what this one is, if this is negative 1.25, then this, it must be counting by 0.25s, and you could tell that by going up as well. So 0.25, 0.5, 0.75. So x equals negative 0.75 is one of my zeros, and x equals, okay, over here I have 2.5 and it's 1 to the right, so that would be 2.75. So x equals negative 0.75 and 2.75. And I also can see that 1 that I got from solving it at the top. Okay, so beat the test. Which of the graphs has the same zeros as the function f of x equals 2x to the third plus 3x to the second minus 9x? Now, first, I have to find the zeros of this function. So let's find a space to do that. We can try, I'm going to get another piece of paper, so if you need to grab another piece of paper, do that. Or if you just want to try to find a spot to scratch that in there, I just don't quite have enough room right now. So I need to find the zeros of this one. So in order to do that, I need to set this function equal to 0. Then I need to factor it. So I'm looking for a GCF here. 2, 3, 9. There's not a GCF of my coefficients, but there is with my variables. So I can factor out an x, and then I'm left with 2x squared plus 3x minus 9 equals 0. Then I could continue to factor this. So throw back for a second. Hold on tight, because remember, we're never done with anything in algebra. It all connects. So I'm going to have to factor this using slip and slide, bottoms up, guess and check, whichever your preferred method was. Okay, grouping, whatever you prefer to use here, we're about to use. I think that most of you used bottoms up, so I'm going to use bottoms up for this particular problem as well. So, 2 times negative 9, so x times x squared plus 3x minus 18. Then I multiplied the a term times the c term. Then I'm going to figure out what multiplies to give me negative 18 and adds to give me 3. So negative 18 will break down, let's just ignore the negative for a second, into 1 and 18, 2 and 9, 3 and 6. Okay, this 3 and 6, if I'm going to get negative and I want to be a positive 3, would work. I would put the negative on the 3 so that I would have a positive 3. Then I can factor into x minus 3 times x plus 6. Now, remember, we're doing bottoms up. This 2 is major important. I have to put that 2 back under each of these numbers. Okay? And then I have to divide it out, if it will divide. If it will not, I slide it in front of that x. So I have x times 2x minus 3 times x plus 3, because this one will simplify, equals 0. Now that it's fully factored, I can find my zeros. So if we need to brush up on factoring, please do so. I can find my zeros by saying x equals 0. That's from this one. 2x minus 3 equals 0. That's from this one. And x plus 3 equals 0. That's from this one. So this is a 0. 0 is a 0. Add 3. add 3 to find this 0, 2x equals 3, divide by 2 on both sides, and x equals 1.5, and then subtract 3 on both sides here, x equals negative 3. So my 3 zeros that I'm looking for are 0, 1.5, and negative 3. So let's look at our graphs. These graphs are tiny, so let me zoom in for a second. So looking at these graphs, this one is negative 2, and that's the only 0, so it can't be that one. This one is at negative 3, and 0, and 1.5. If we go back to this, we were looking for 0, 1.5, and negative 3. So this is my correct answer. Sorry about that. But we can check the other two just to be sure that they don't cross at the same places. Now, if we wanted to be sure, we needed to solve it like that. But as a side note, we really could have eliminated this one because it only has 1 0, and there's going to be more than 1 0 in this function. We can tell once we factor it, we know there's definitely going to be more than 1 0. And then we can also eliminate this one because this is a quadratic. This would have a squared instead of a to the third up here. Okay, so we're at either this one or this one, but then this one crosses at, it looks like negative 2, doesn't cross at 0, and then crosses again at positive 2. So when we started factoring and we got this x right here, and we knew it would cross at 0, we could have eliminated this one as well and gone with this one. However, if there were two that were graphed very similarly and both graphed at 0, we would have had to continue this problem and get specific with those 3 zeros right there. So, if you have any questions, let us know.